Hello everyone, Miss Meek here, and today we are going to be talking about dot plots. Dot plots is another visual representation of data on a number line. Dot plots are actually really cool because they represent every single data point that you have. So this is an example of a dot plot, and as you can see, I have dots over certain numbers. Every dot represents one of those numbers. So for example, if I was to list this data out, there's 1 dot over 1, so that would be 1. I have 3 dots over 2, so that means that I have 3 2s. 2 dots over 3, so 2 3s. 1 4. I don't have any dots over 5, so that means I don't have any 5s. And then I have 1 6, and then there's 2 dots over 7, so 2 7s. And then I don't have any dots over 8, which means I don't have any 8s in my data. So if I was to list out my data, this would be it right here, okay? 1 2 2 2 3 3 4 6 7 7. So it's really cool because a dot plot tells you literally every data point that you have in your data. This is different than like a histogram or a box plot. Box plots do not tell you every single data point that you have. It gives you a summary of 5 of the data points, the median, the quartile 1, quartile 3, the minimum, and the maximum, but it doesn't actually tell you every single number that you have. Dot plots do that. Now, dot plots come with their own set of vocabulary, so a couple of things to note. First of all, when you have the tallest tower here, which 2 has the most numbers, okay, there's 3 2s, so there's 3 dots for 2. This is called the peak. We know it actually by another name. We know it as the mode, okay? It's the number that's there the most. But in dot plot language, they call it the peak. Now, when you don't have any data, like right here where this 5 is, this is called a gap. It's a number or numbers that don't have any data at all. So 5 would be considered a gap. When you have data clustered together or grouped together, like what we have right here and right here, these are actually called clusters. So that is when you have multiple dots all together and there's no gaps. Gaps separate clusters. So that's why we have 2 clusters in this data, because there's a gap at 5. Now, if my graph had been extended further out, so I'm going to extend my graph further out, 9 and then 10, and we had a dot all the way over here by itself, okay? Sometimes when the dot that's way over here by itself is separated out with a good distance, this can sometimes be an outlier. Now, for this data, this would probably not be considered an outlier, but on a bigger dot plot, if you have a dot that's way over there by itself, separated from the data, it's way bigger or way smaller than the rest of the data, that would be considered an outlier in a dot plot. So like I said, for this data though, 10 is actually not separated out enough to be a dot plot or to be a outlier on this dot plot. So I don't know if I would consider it an outlier. However, if on a bigger graph with more data and it's more spread out, that is possibly one way to identify an outlier on a dot plot when you have a single dot separated from the rest of the data. All right, so that is the overview of a dot plot. We're going to go ahead and talk about how do we make one. Well, how do you create a dot plot? You literally put dots over numbers. So here is my data. I'm going to put a dot at 19. I'm going to put a dot at 12. And again, guys, when you put these dots, they're supposed to be a visual representation of how much you have. So try to keep the dots spaced evenly, because if you cram them all together, it makes it hard to read the dot plot. So I'm putting a dot at 15, 16, 11, 10, and then 2 more 13s. Okay? And so from this graph, I can easily see that I have a cluster, I have a gap, possibly an outlier with 19. I'd have to do some math to figure that out. And then I can also see I have a peak at 13, which means that 13 is the mode. It's the one that appears there the most. And so you can get a lot of information from a visual representation like this. They're really, really awesome because, again, they tell you every piece of data that you have. So speaking of getting information off of a dot plot, let's do that. Here's a dot plot that I've already made. So let's pull some information off of this. First of all, they're asking for the median, the mode, the range, the mean. We can do this on the dot plot. So let me kind of give you a couple ideas of how to do this. First of all, for the median, my dots are already in order from least to greatest. I can write the data out. It's not hard, okay? 1, 4, 4, 4, 4. There's 4 4s. 2 5s, 1 6, 7 7. I can write the data out. It's not very difficult to do that at all. And then I can find the median. So by crossing out the biggest and the largest at the same time, I can go through until I'm left with 1, which actually I'm left with 2. So remember, when we have 2 medians, we have to add those numbers together and then divide by 2. Okay, and so I get 4.5 as my median. Another way you can do this, and you have to be extremely careful when you do it this way, is you can use the dots and cross the dots out. So like I could cross out 1 and 7, and then I could go to 4 and cross out 4 and 7, 4 and 6, 4 and a 5, and then see that you're left with a 4 and a 5, and then average them together. You just have to be extremely careful doing that, because you can get like you're cross-eyed and cross out too many dots or get off. And so I would really suggest you list out your numbers and do it like the way that I did it down here. Okay, that's going to be a lot easier for you. The mode, of course, is going to be the easy one because it's the one that is there the most. It's going to be the tallest tower or the peak, and that is going to be 4. The range is going to be your highest dot, which is at 7, and your lowest dot, which is at 1. Remember, so that's going to be 7 minus 1, which is 6. And then the mean is where we're going to add all of our dots together. So again, there's another trick to do this one in kind of like a shortcut. I have 1 here. Here I have 4 4s. 4 times 4 is 16. Here I have 2 5s. That's 2 times 5, which is 10. I have 1 6, and I have 2 7s, which is 14. So I can add together the numbers kind of like a shortcut and do it this way. And then go back and count how many dots I have and divide by that number. So when I do this, I get 17 plus 10, which is 27. 27 plus 6 is 23. And then 23, I'm going to write that down. 23 plus 14 is going to be 37. Did I mess something up? Did I do something wrong? That's possible. 17, 27 plus 6 is 33 because I can't add today. All right, so that's 33. There we go. And so then when I add all that together, I get 47. Okay, let me redo that. All right, now we go back and we count how many dots I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 dots. So remember, I'm going to take 47 and we're going to divide by how many dots there are, which is 10. And so that means my mean is going to be 4 and 7/10 there, okay? And then they can ask you other questions like, where is the peak? Well, remember, this mode here is also known as the peak. So the peak is at 4. They may ask you how many data points are between 4 and 7. So you would count the dots. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 data points in between 4 and 7. That's a cluster, by the way. So I'm wondering, they could ask you like, hey, where is there a cluster? Or you could say between 4 and 7. They could ask you, is there any dots by themselves or gaps or anything? And so you could say, hey, there's actually a gap right here between 2 and 3. So they can ask you a lot of different questions about these dot plots because you have literally every single data point. So you can find the median, the mode, the range, the mean. You can even find the interquartile range if they wanted you to. You could take this data and turn it into a box plot or turn it into some other different type of plot. So again, there's a lot you can do with these, and they're really, really cool. I hope that this cleared up any confusion about creating a dot plot, or getting information off of a dot plot. I'll talk to you later. Bye.